All right, so welcome to your right triangle trig packet. This is a separate little note packet because it's a separate little shape. Remember I told you trigonometry is the study of triangles and circles and how they relate. So you have that little first packet is for circles. This new one, very short, should be some easy points for you, is about triangles. Specifically right triangles, triangles that have a 90-degree angle in them. By definition, a triangle is not right. A triangle is not right if it doesn't have this 90-degree angle in it. So, little heads up on that. You're looking for this box. It's going to be in everything we do in this section. Before I jump into SOHCAHTOA, I need to break down the anatomy of the right triangle. So I had you point your eyes at that right angle there. It's a 90-degree angle, or pi over 2, since we're studying radians. 90 degrees is not actually the angle we're going to worry about too much, though. It's usually these two missing angles right here. You might recall from the beginning of our time together, theta is just the measure of an angle, right? So in this case, if this is our theta, and you look all the way across the circle, we're going to call that side our opposite side. So that side right there is called our opposite side. I'm going to abbreviate. I'm just going to use the letter O for opposite. A big kid word for next to theta, the word next to, just means adjacent. So right now I'm standing adjacent to my desk. I'm next to my desk. I'm actually leaning on my desk. Adjacent just means, if you haven't heard that word before, it means next to. So this angle right here, or this side I should say, is the adjacent side to theta. I'm going to abbreviate that with an A. And then the side always across from our right angle, that's our hippopotamus. Just kidding. That's the word hypotenuse. So it's all the way across from the right angle. I'm going to abbreviate with an H. The hypotenuse is actually always, I don't know if you know this or not, it's always your largest side. It's because it's across from the largest angle. So the hypotenuse, not only is it all the way across or opposite from the right angle, because the 90-degree angle is going to be the largest angle in a right triangle, it has to be our largest side. So if you're looking at 3 numbers, the hypotenuse is really easy to pick out because the hypotenuse is just the biggest number. From this, we introduce or reintroduce the idea of SOHCAHTOA from your geometry classes. We're going to get into something called right triangle trigonometry. And just to build those definitions for you, remember that the sine of an angle, I'm just going to circle some things here. The sine of an angle is always equal to the ratio of the opposite side over the hypotenuse. So that's our SO in SOHCAHTOA. Ka comes from the idea that the cosine of an angle theta can be built out of the ratio of stacking your adjacent side, so the side next to theta, over the hypotenuse. So cosine is always your adjacent over your hypotenuse, so that's our ka. And then tangent is equal to the ratio of the opposite side. Apparently I can't spell opposite, sorry. Opposite side over the adjacent side. So that's our TOA in TOA. TOA. I think that one's fun to say. SOHCAHTOA. So all I need to do, or all I need to have you do for tonight, super quick and easy, it's that page 71 assignment. I just want you to build your fractions. That's it. So let me show you how to build your ratios. They did the sine of B for us, or sine of A. See this sine of A? All I want you to be able to do tonight is write 8 over 17, like write your fractions that represent the ratio. So let's talk about how they got this first answer. Do you see angle A? You're standing on it. If you're standing on it and you're trying to find sine, you need to think so, which is opposite over, the hypotenuse. They didn't give us the hypotenuse. Do you remember how to find it? Well, I'll tell you it's 17. I give you all the sides tonight. We'll do the Pythagorean theorem with it tomorrow. But it's a squared plus b squared equals c squared. So 225 plus 64, or yeah, equals your 289, and then the square root of that is 17. But we'll go through that a little bit more tomorrow. So the sine of angle B now, if we're standing at B and we need to do opposite over hypotenuse, all the way across from B is our opposite side, and our hypotenuse is always that biggest side of the triangle. This guy's going to be 15 over 17. Cosine of angle A, that's adjacent over hypotenuse from up top. So you pretend you're standing at angle A. If you're standing at angle A and you're looking for the adjacent side, oops, sorry, I'm off my screen here. The kind of wand is that? All right, sorry. If you're standing at angle A and you look for the adjacent side, the side next to angle A, you're looking at 15, and the hypotenuse is still 17. So this next ratio here is just 15 over 17. And then you reduce the fraction, but 15 over 17 doesn't reduce. Cosine of B, adjacent over hypotenuse. So the adjacent side is again next to angle B. Adjacent over hypotenuse is 8 over 17. And tangent is just opposite over adjacent. So cosine of B is 8 over 17. Tangent of A, go ahead and take a look at angle A, pretend that we're standing there. If tangent is defined as our opposite over adjacent, standing at A, the opposite side is 8, the adjacent side is 15. So 8 over 15 is the tangent of angle A. The tangent of angle B, so jump across our triangle here, and keep in mind we're asking for tangent, so we're thinking TOA, opposite over adjacent. The opposite side is 15, and the adjacent side is 8. So opposite your opposite side is 15, and your adjacent side is 8. And that is how we write our ratios for sine, cosine, and tangents. You just want to think SOHCAHTOA.